Hello students. So today we are going to start with the discussion of paper 27th of January evening shift, and these questions in the paper we have which are based on memory. So maybe there is some variation will be there. So while solving we will focus more on that conceptual part, right? Okay. So in this first question, which is based on the indefinite integration, and we are going to use method of substitution. So in this, if we start with just dividing x power 6 in the numerator and the denominator, so what we are going to get, we are going to get, if we are dividing by x power 6, so in the numerator we are getting x square minus 1 by x power 4 dx as it is, and in the denominator also when we are dividing this by x power 6 we are getting x power 6, 3x power 6 divided by x power 6, that is 3, and 1 by x power 6 we are getting, and tan inverse of x cube plus 1 by x cube as it is. Now we can write this as x cube whole square, 1 by x power 6 we can write it as 1 by x cube whole square, plus this 3 we are writing as 2 plus 1, so 2 into x cube and 1 by x cube. Now we can see that this is a square plus b square plus 2ab plus 1. So now this integral we have is x square minus 1 by x power 4 dx whole divided by x cube plus 1 by x cube whole square plus 1, and tan inverse of x cube plus 1 by x cube as it is. Now if we substitute tan inverse of x cube plus 1 by x cube as t, then differentiating both sides, what we are going to get is 1 plus x cube plus 1 by x cube whole square. Then differentiation of this x cube plus 1 by x cube will be 3 times of x square minus 3 times of x 3 times of 1 by x power 4 dx is equal to dt, we can write. Now if we see, so this part x square minus 1 by x power 4 divided by this dx, we can replace this as dt by 3. So now we are getting integration dt by 3, so we can take 1 by 3 outside, dt divided by tan inverse of this we are calling it as t, so that is dt by t. Now this is nothing but 1/3 of ln of mod t plus constant of integration, and t we can replace as tan inverse of x cube plus 1 by x cube, so we are getting answer 1. So this was a relatively easy and very basic problem of from the indefinite integration. Okay, so in that in this second question, this is a trigonometric equation is there, has exactly 7 solution in the interval 0 to n times of pi by 2. Now we have to find the least value of n where n belongs to integer, and then after finding n we have to calculate this sum, right? So we can write this as 2 times of tan square theta, we can write it as sec square theta minus 1 minus of 5 sec theta minus 1 equal to 0. So we are getting one quadratic, that is 2 of sec square theta minus 2 minus 5 sec theta minus 1 equal to 0. So this is 2 of sec square theta minus 5 of sec theta minus 3 equal to 0. We can factorize this, so this is 2 of sec square theta minus 6 times of sec theta plus sec theta minus 3 equal to 0. So 2 sec theta if we are taking common, we are getting sec theta minus 3 plus 1 we are taking common, so we are getting sec theta minus 3 equal to 0. So from here we are getting 2 of sec theta plus 1 equal to 0, and sec theta is equal to 3. Now sec theta is equal to minus half, which is not possible because we know that range of sec theta is from minus infinity to minus 1 union 1 to infinity. So this we are going to reject. Now we are getting that sec theta is equal to 3. So we can write it as cos theta is equal to 1 by 3. Now they are saying that exactly 7 solution in the interval. So we have to find n. To find that this interval, to find this interval, we have to draw the graph. Okay. So now that cos theta graph if we are drawing, so it is starting with 1 and like this it will go. Okay, now that y is equal to 1 by 3, we want y is equal to 1 by 3 line, so this line will be like this, that is y is equal to 1 by 3. So the point of intersection, we need 7 solution. So this is 1 2 3 4 5 6 7. Okay, perfect. So this is pi by 2, this will be pi, this is 2 pi, this will be 3 pi, 4 pi, 5 pi and 6 pi. So we have to take interval in 0 to n pi by 2. So this interval we know, this is pi by 2. Similarly, this interval, this length will be pi by 2. So this point will be 6 pi plus pi by 2, that is 13 pi by 2. Correct? So now we have that interval 0 to 13 pi by 2, in which we are getting exactly 7 solutions. So from here straightforward we can say that value of n is 13. Okay, now going back to the question, what they are asking after this, they are asking the sum of this series. So nothing is there, we have to just put the value of n, and value of n is 13. So we can take 2 power 13 outside. Now we have to calculate this sum, that is nothing but k is varying from 1 to 13 and k. So this is 1 by 2 power 13, and sum of first 13 natural number will be 13 into 13 plus 1, that is 14. So 13 into 13 plus 1, that is 14 by 2. So we can cancel this 14 by 2, 14 by 2. So we are getting 7. So 7 into 13 is 91. So that answer will be 91 divided by 2 power 13. So that is our answer, and it is also very easy problem we can say. And somehow this question is from trigonometry equation, and recently JEE Mains announced that that is not the part of syllabus, so we can expect some bonus marks. But now for solving this, that is 91 by 2 power 13, that is option B. This differential equation, this is not homogeneous. Okay, so this is not a homogeneous differential equation, so first we are going to make this homogeneous. Okay, so we can write this dy by dx equal to, we have x minus 1 and y minus 1, we can write minus 2 as minus 1 minus 1. Correct? In the denominator also we are writing x minus 1 minus of y minus 1. Okay, so now if we replace x minus 1 by, let's say, capital X, and y minus 1 by capital Y, so from here dx will be capital, the d of capital X, and dy will be d of capital Y. So now we can replace this by dy by dx equal to x plus y divided by x minus y. Now this is homogeneous differential equation, and we know very well that how to solve this. So we are going to replace y by vx, then differentiation dy by dx is equal to v plus x into dv by dx. Okay, now if we are replacing these value, so what we are going to get here, we are replacing dy by dx as v plus x into dv by dx is equal to, here we can replace x plus vx and x minus vx, we can take x common, so 1 plus v and x 1 minus v, we can cancel x x, so we are getting 1 plus v and 1 minus v. Now here only if we shift this v this side, so what we are going to get is x into dv by dx is equal to 1 plus v divided by 1 minus v minus v. Taking LCM, we are getting 1 plus v minus v plus v square divided by 1 minus v. We can cancel this. So now here we are getting x dv by dx is equal to 1 plus v square upon 1 minus v. So now this is nothing but, we can solve this very easily by using variable separable method. Okay, so now we got x into dv by dx is equal to we are getting 1 plus v square upon 1 minus v. So 1 plus v square upon 1 minus v we got. So we can write it as 1 minus v divided by 1 plus v square dv is equal to dx by x, right? So now to integrate this, we can separate this integral as 1 plus v square dv minus of v divided by 1 plus v square. To make this in the form of f dash x by fx, so we can multiply and divide by 2 dv dx by x, right? So this is directly we can write tan inverse of v. So this is tan inverse of v, and v we have that y is equal to vx. So we can write this as tan inverse of v. So we are writing v as y by x, and y, capital Y, we are replacing with y minus 1, and capital X we are replacing with small x minus 1. So we are getting y minus 1 by x minus 1 minus half of this. This is the form f dash x by fx dx. So we can write it as ln of mod of fx, correct? So we can write this as ln of 1 plus v square, and v is what? V is y by x, and capital Y we are replacing simultaneously. So we can write it as y minus 1 whole square divided by x minus 1 whole square. I hope this is clear. Equal to ln of mod of capital X. So mod of capital X, we can replace that x by x minus 1. So mod of x minus 1 plus constant of integration. Now to calculate this constant of integration, some information we need. So, and before that we can just write this as, we can take this power, this number in the power by using the property of log. So this will be root over 1 plus y minus 1 whole square by x minus 1 whole square. That is equal to ln of x minus 1 plus c. Now our concentration is to find the value of c. To find the value of c, some information must be given. So okay, so they gave y0 equal to 2. It simply means when we are going to put x is equal to 0, y value is 2. Okay, so if x is equal to 0 we are plug in here, so y value will be 2. So we can write tan inverse, this will be 2 minus 1, 0 minus 1 minus of ln root over 1 plus this will be 2 minus 1. So 2 minus 1 is 1, and minus 1 is square, minus 1 is square is 1, is equal to ln of x we are putting 0. So ln of mod of minus 1 is ln 1, that value is 0. So c, so tan inverse of minus 1 is basically minus of pi by 4 and minus of ln root 2. So that c value we are getting is this. Okay, so now c value we got this. Now we are utilizing this space, so we can put this back. So tan inverse of y minus 1 by x minus 1 minus of ln of root under 1 plus y minus 1 whole square by x minus 1 whole square is equal to c value we are getting minus pi by 4 minus of ln root 2. Okay, now they are asking, what they are asking? They are asking y at 2. They are asking value y at 2. Okay, so y at 2 value, so we can use these options. Okay, so if we are choosing, let's start with that option 1. So if we are choosing, let's say y at 2 value is 0. So if we are putting x is equal to 2, y value 0, from the options we are checking. So if x is equal to 2, we put y value is 0, this will be tan inverse of minus 1, that is minus pi by 4. Okay, and y value 0 and x value is 2, so 2 minus 1 is, okay. So if we put x is equal to 2 here, so we are going to get 2 minus 1 is 1, and y value is 0, so that is 1. So we are getting ln of root 2, so that is equal to minus of pi by 4 minus of ln root 2. So now we can say that y at 2 will be 0. So that is our correct choice is option 1 only. Okay, so this was a little lengthy problem, so we can rate this problem as moderate. Okay, so this problem is based on the definite integral, and this type of problem which are very just one of the example I can say that this is something in this form, that dx by 3 plus 5 cos x type of problem, but here we do not have any value, we have some in terms of some unknown, that is a. So how to proceed with this problem? Let's begin. So let's say this is I equal to this. So let's say this is first. Now we are using the property that is king property. So we can write I as 0 to pi, that will be dx, and we are replacing x by pi minus x. So what we are going to get, cos of pi minus x is basically minus of cos x. So we are getting in the denominator 1 plus 2a cos of x plus a square. Let's say this is second. If we add 1 and 2, what we are getting, we are getting 2 of I is equal to, limit is same, 0 to pi. In the numerator we are going to get 1 plus a square minus of 2a cos x and plus of 2a cos x, and 1 plus a square 2 times. So we can write this as 2 times of 1 plus a square. In denominator this is 1 plus a square minus of 2a cos x, and this is 1 plus a square plus of 2a cos x in the multiplication. So we can use the formula a square minus b square. So we can write it as 1 plus a square whole square minus 2a cos x whole square, that is 4a square cos square x dx, right? So now we can cancel this 2 with this 2. We know another property, that 0 to 2a fx dx, we can write it as 2 times of 0 to a f of x dx, provided f of 2a minus x is equal to fx. So this function is following this property, so we are applying this property. So now we can write this as I equal to 0 to pi by 2. We can write this pi as 2 into pi by 2, right? So we can write this as 2 times of 0 to pi by 2, 1 plus a square divided by 1 plus a square whole square minus 4a square cos square x dx. Okay, now we want to solve this problem. So while solving this problem, this is the very standard problem we have, format we have. So we have to divide numerator and denominator both by cos square x. So if we divide numerator and denominator both by cos square x, we can write 1, that I equal to, that is 2 times of 0 to pi by 2, 1 plus a square, and if we divide this by cos square x, so we are going to get sec square x. In the denominator it is 1 plus a square whole square divided by cos square x will be sec square x and minus of 4a square. Okay, let's once check. Okay, so this is 1 plus a square whole square sec square x minus 4a square, correct. Now we can write this sec square x as 1 plus tan square x. Why we are doing this? So if we are doing this, so we will be getting tan square x term in the denominator. Then we can substitute tan x as t. That will help us to solve this problem by using substitution. So it is bit lengthy but not tough. So this is 1 plus a square sec square x. This 1 plus a square whole square, we can write it as 1 plus tan square x minus 4a square. Now we can write this as 0 to pi by 2, 2 times 1 plus a square sec square x. This part will be 1 plus a square whole square plus 1 plus a square tan square x minus 4a square. If we simplify this part, what we are going to get is 1 plus a square whole square. So we can write it as 1 square a square whole square and 2a square and minus of 4a square. So we can write this as 1 minus a square whole square. Okay, so now we can write this as integral 0 to pi by 2 twice of that, and this is 1 plus a square sec square x divided by this part we can replace with 1 minus a square whole square plus 1 plus a square tan square x. Now we can easily solve this by using substitution. So if we put tan x as t, we can write sec square x dx as dt, right? Now limits are there. So when x is tending to 0, t is tending to 0, and when x is approaching to pi by 2, t is tending to infinity. So now we can write this as integral twice of 0 to infinity after changing limit, and 1 plus a square sec square x dx as dt. So this is dt divided by, now if we take, and this is 1 plus a square whole square, correct, because we are multiplying this inside. Okay, so if we take 1 plus a square whole square common in the denominator, what we are going to get is 1 minus a square upon 1 plus a square whole square, plus we are replacing tan x as t, so we are getting t square, and that is dt we have already written. So now we have I equal to 2 of 0 to infinity, or better if we write here. So now we can write that we are taking 1 plus a square common from the numerator, and from the denominator we have 1 plus a square whole square, and this is dt divided by, this is in the form of x square plus a square. So okay, just write 1. So we are getting 1 minus a square whole square, 1 minus 1 plus a square whole square plus t square. So directly we can write now formula, and limit is from 0 to infinity. So okay, I guess you are done with this. So we can use some space here. So okay, so after this we can write here that I equal to 2 times of, so 1 plus a square we can cancel one part, so we are going to get 1 plus a square. Here power 2 is there. Okay, so it is 1 is cancelled. Now this is 1 by a. This is tan inverse. So 1 by a tan inverse of x by a. So we can write this integral as 1 plus a square upon 1 minus a square tan inverse of x by a. So that is t by a will be 1 plus a square upon 1 minus a square. Now limit is from 0 to infinity. If we put 0, this will be 0. If we put infinity, this value will be pi by 2. So now this is I equal to, we are getting 2 times 1 plus a square, again we can cancel, so 1 minus a square we left with, and this value will be pi by 2. So this 2 and 2 we can cancel, so answer will be pi upon 1 minus a square. So if we are going back to the question, so our answer will be pi by 1 minus a square. So this will be the final answer. Okay, so we can replace any one of that problem, because these problems are based on memory. So but the conceptual part is, I hope, clear to all of you. Okay, so this problem is very simple. I can say that they are asking that the 20th term from the end of the progression, and this is a given AP, right? So that method 1 we can say that nth term, rth term from the end, we can write it as n minus r plus 1th term from the beginning. To find answer from this method, we need to calculate first value of n, so we can solve. Otherwise, whenever this type of problem is there, we can write that sequence in the reverse order, so that last term will become the first term. So if we simplify this, this will be minus of 517 by 4. So we can write this as 517 by 4, then next term will be there, and this term will be 77 by 4, and next term will be 20. So for this sequence, we can write common difference, that will be 20 minus 77 by 4, that is 80 minus 77 by 4, that is 3 by 4. So the difference, common difference we are getting is 3 by 4. Now we want the 20th term in this sequence. because we wrote this sequence in the reverse order. So now we can write that T20 will be, first term will be minus of 517 by 4 plus 20 minus 1. So that will be 19 into D. In that case, D is 3 by 4. So that is minus 517 by 4 plus 57 by 4. So that will be minus of 460 by 4. That is minus 115. So I hope this is clear to all of you. Okay. So in this problem, an urn means a bag is given which is containing 6 white and 9 black balls. Two successive draws of 4 balls are made without replacement. Okay. Then the probability that the first draw gives all white balls. So it means all 4 balls which we are drawing in the first attempt, all are white. So the required probability is probability of 4 white, and in the second draw it gives all black. So 4 white and 4 black balls. This is our required probability. Okay, and the condition is without replacement. Okay, so we can write this, that required probability. So first we have to take 4 balls, 4 white balls. So we have to choose 4 white balls from 6. So we can write it as 6C4, and total available balls we have 15. So is 15C4, and multiplied by, then we have to calculate the probability that 9 out of 9 balls, that next in the next attempt we are drawing another set, another 4 balls, so they are black. So we have to write 9C4 but without replacement. So first we have already drawn 4 balls, so 15 minus 4, that will be 11C4. So this is our required probability. Now we have to simplify this. So 6 into 5 into 4 into 3 divided by 4 will be cancelled. Actually 4 factorial will be there, that will be cancelled. So 15 into 14 into 13 into 12, then 9 into 8 into 7 into 6, and this is 11 into 10 into 9 into 8. So 9 8 9 8 we can cancel. This is 11, and this 15 we can cancel here, and this 6. So we are getting 2 here, this 2 here, and this we can cancel 3, this we are getting 7, this 7 we can cancel, and this we can cancel as 5. So what we are left with, we left with 3 divided by 13 is there, 11 is there, and 5 is there. I hope this is correct. Okay, so we can evaluate this. This is 3 and 13 and 55. So 13 into 55. So 55 into 10 will be 550, and 55 into 3 will be 165. So we are getting 517. So 3 divided by 715. So this is our correct choice. So this was easy problem. Okay. So this problem is based on the finding the domain of the composite function f of gx. So the basically, to find the domain of f of gx, uh, we have to take care of two things, that what is gx when gx is defined, and all those values where gx is not defined we have to remove those values, and values where f should be defined for where gx is defined. Okay, so gx is not defined at x is equal to minus of 5 by 2, so that we have to remove from the r. Okay, and another we have to check for f of gx. So if we write f of gx from here, we can write, we have to just replace x by gx. So we can write in this definition, so we can write 2g, I am writing just gx as g only, for plus 3 divided by 2 of g plus 1. So we want that 2g plus 1 should not be equal to 0. So gx should not be equal to minus half. That we have to solve for. So gx is not equal to minus half. What is gx? So gx is mod of x plus 1 upon 2x plus 5. This should not be equal to minus half. So we have to make case when x is greater than equal to 0 and when x is less than 0. When we are going to solve this, we are not going to get any value. So we are getting x 5 from here. So final answer will be r except minus of 5 by 2. So that is relatively very easy problem. from the chapter functions. Okay, so this problem is based on inverse trigonometric function. We have to solve this equation. So we can apply that formula tan inverse of a plus tan inverse b, that is a plus b, tan inverse of a plus b, that is tan inverse 3x, divided by 1 minus x into 2x, so that is 2x square is equal to pi by 4. So we can write this as 3x divided by 1 minus 2x square. Tan pi by 4 is 1. So this is 3x is equal to 1 minus 2x square. We can shift this 2x square this side. So 2x square plus of 3x minus 1 equal to 0. Now we have to find for the positive real values of x. So from this, okay, so we can find this solution of this quadratic. So that is x is equal to minus 3 plus minus root over b square, that is 9, minus 4ac, minus 4 minus 1 is plus 4, into 2 will be 8. So root over 17 by 2 into a is 2, so that is 4. So now we are getting x is equal to, we can write here x is equal to minus 3 plus root 17 by 4. Another will be minus 3 minus root 17 by 4, that will be rejected. So we are getting answer as root 17 minus 3 by 4, that is our choice 3. So this was very easy problem from the chapter ITF. Okay, so in this problem, two lines are given which are containing that some region in which they are containing origin. Then we have to find the set of values of a for which the point this is lying in the same region. Okay, so we can draw these lines. So this line is 3x minus y plus 1 equal to 0. That is, let's say L1. And if we put x is equal to 0, we are going to get y equal to 1. So this is 1.0 comma 1. And if we put y equal to 0, we are going to get x is equal to minus 1 by 3. So that is minus 1 by 3 comma 0. So if we join these 2 points, we are going to get this line. So let's say L1, that is 3x minus y plus 1 equal to 0. Similarly, let's say L2 is x plus 2y minus 5 equal to 0 we have. Now if we put y equal to 0, we are going to get x is equal to 5. So x is equal to 5 comma 0. This is one point. To draw the line, we need another point. So let's say put x is equal to 0. So y is equal to 5 by 2. So that will be 0 comma 5 by 2. Let's say somewhere here. So if we join these 2 points, we are getting line L2, that is 2x, that is x plus 2y minus 5 equal to 0. Right? Now, with respect to L1, if we put origin in this, we are getting positive 1 plus 1 actually we are getting. So that is positive. So with respect to line 1, that that point P is lying in the same side in which origin is lying. Okay. So in L1, if we put point P, this should give the same sign. So L1P should be greater than 0. And in L2, if we put origin, we are getting minus 5, that is negative. So with respect to L2, this point P, let's say this point P is a square comma a plus 1. So when we are going to put that point P in L2 line, this should give the same sign because they are on the same side with the origin. So this should be negative. So if we solve this L1P and L2P, two inequalities basically we have to solve. After solving these two inequalities, if we take intersection, we will get the set of values of a. So that will be our option B. So this is just based on position of point with respect to line. I hope this is clear to all of you. Okay, so in this problem they are asking the number of points where gx is not differentiable. Okay, so in such a type of problem, actually it is minimum of ft where t is varying from 0 to x, where x is from 0 to 1. Okay, so if we draw that graph of fx, so we can draw the graph of fx. It is downward parabola and roots we know 0 and 6, 0 and 6. So this is the downward parabola. Okay, but we are interested in this definition for x belongs to 0 to 1. So in x belongs to 0 to 1, if we look, if in the interval x belongs to 0 to 1, if we look, this f of t minimum. So that will be fx. So minimum of fx in 0 to 1 will be 0. So if we draw the graph, so we are getting in between 0 to 1, we are getting 0, right? And at 1, from 1 to 2, the definition is 3 plus x. So this is the graph. And at 1, this value 3 plus x will be 3 plus 1, that is 4, and at 2 it will be 5. So this is the graph. So now we can say that there is one point where this gx is not differentiable. So answer is option A. I hope this is clear to all of you. So in this problem, that one hyperbola is given and another ellipse is given. Then ellipse passes through the foci of the hyperbola, and the product of their eccentricity is 1. Okay, then the length of the chord of the ellipse which is passing through 0 comma 2, that we have to evaluate. Okay, so if we start with that, the given hyperbola, we have x square by 16 minus y square by 9 equal to 1, and that we can evaluate its eccentricity. So we can write b square is equal to a square e square minus 1. B square is 9, a square is 16, e square minus 1. So 9 by 16 plus 1 is equal to e square, that will be 25 by 16 is equal to e square. So e we are getting 5 by 4. So e of the hyperbola is 5 by 4. So on the given information that e1 into e2 is 1, so eccentricity ee, that is 4 by 5, that is eccentricity of ellipse. Okay, now if we know the eccentricity of the hyperbola, we know its foci will be plus minus a comma 0. A value we have 4, so that foci will be plus minus 4 times of e is eccentricity, that is 5 by 4. So this is plus minus 5 comma 0. Now it is given that the ellipse passes through the foci of the hyperbola. So ellipse equation we have x square by a square plus y square by b square equal to 1. Now this is passing through plus minus 5 comma 0. So we can put plus minus 5 comma 0 into this, so that x square will be 25 by a square, and this part will be 0 equal to 1. So a square we are getting 25. Now using formula for the eccentricity, we can write b square is equal to a square 1 minus e square. We can write, and value we have 4 by 5. So that b square we can calculate from here, that is 25 times 1 minus 4 by 5 whole square. So b square is equal to 25, and 25 minus 16, that is 9 by 25. So b square value we are getting 9. Now x square by a square is 25, b square is 9. So now we have ellipse. So if we know that the equation of ellipse, now we have to find the length of chord to the ellipse which is passing through 0 comma 2, and it should be mentioned and parallel to x-axis. So it is passing through the point 0 comma 2 and parallel to x-axis. So we can take it as y equal to 2. If we put y equal to 2 here, we will be getting uh, x square by 25, and y equal to 2 if we put, so this is 4 by 9 equal to 1. So x square equal to, or x square by 25 equal to 1 minus 4 by 9, that is 5 by 9 x square by 25. X square equal to 5 into 25 by 9. So from this we can write x1 equal to, so two values basically we are getting, so that will be 5 root 5 by 3, and x2 minus of 5 root 5 by 3. So length of the chord will be mod of x1 minus x2. So 5 root 5 by 2 minus, so that will be twice of that. So we can write 10 times of root 5 by 3. Okay. So our answer is 10 times of root 5 by 3. So it has to mention that this chord to the ellipse is passing through the point 0 comma 2, as well as it is parallel to x-axis. So this is a relatively easy problem. Okay, so in this problem, that the position vector of the vertices of the triangle ABC are given. So let's draw. So that A is 1 2 3, B is we have 1 1 3, and C we have 2 1 3. Okay, now that L is the length of the angle bisector of the BAC. BAC. So this angle bisector is there. So this length they are asking. Okay. So we know that angle bisector divides the opposite side. Let's say this is D in the ratio of AB is to AC, in the ratio of the adjacent sides. So we can calculate length of AB. So 1 minus 1 0, 2 minus 1 is 1, 3 minus 2. So this length is 1. So this length of AB is 1, right? So this length if we calculate, so this is 2 minus 1, 1 square, 2 minus 1, 1 square, 3 minus 3 is 0. So that will be root 2. So this ratio is 1 is to root 2. Now we can calculate point D by using section formula. So that point D we can evaluate by using point D we can calculate by using section formula. So this point will be there. Now after evaluating D point, we have to just apply the distance formula, and we will be getting the length of the angle bisector. So I hope this is a very easy problem, and after solving this we will be getting answer as option. So in this problem the two sets are given, A and B, and number of element in set is M, number of element in set B is N. So their difference, the number of subsets, the the difference is 56. We have to find the value of m and n, then we have to evaluate 2m plus n. Okay, so that number of subsets will be 2 power m minus 2 power n is given 56. So we can write this 56 as 2 power 3 into 7. 2 power m if we take or 2 power n if we take common, so we are going to get 2 power m minus n minus 1 is equal to 2 power 3 into 7. So 2 power n equal to 2 power 3, so n value we are getting 3, and 2 power m minus 1, m minus n minus 1 is equal to 7, so that will be 8. So we can write it as 2 power 3, so that is 2 power m minus 3 is equal to 2 power 3. So m minus 3 is equal to 3, so m value is 6. So m we are getting 6 and n we are getting 3, so that will be 2 into 6 plus 3, that is 12 plus 3, that is 15. So our answer is 15. So this was very easy problem, or we can just by hit and trial we can say m is 6 and n is 3. So I hope this is clear to all of you. Okay, so in this problem a matrix of order 2 cross 2 is given, where I is an identity matrix of order 2, and the values of lambda are given to us, that is minus 1 and 3. So we can write it as lambda minus 3 into lambda plus 1 equal to 0. This will represent the characteristic equation of the matrix. So that will be lambda square minus 3 lambda plus lambda, that will be minus 2 lambda, and minus 3 equal to 0. So by Carey Hamilton we can say that matrix will satisfy this. So a square minus 2 of a minus 3 of the identity matrix is equal to null matrix. Okay, now we know that that sum of that values of lambda, that is 2, is going to represent the trace of the matrix. So now we know that trace of matrix is 2. Okay, so from here we can write a square is equal to 2 of a plus 3 of the identity matrix, and identity matrix is of order 2, so we can write 1 0 0 1. So trace of that this identity matrix of order 2 is 2. Okay, so we have to write the, we have to find the trace of a square. They're asking the trace of a square, so we can write trace of a square. We can keep that constant outside, that will be 2 times of trace of a plus 3 times of trace of identity matrix, that is 2. So 3 into 2 is 6, and 2 into 2, so that is 4. So 4 plus 6 is 10, so we are getting value 10. So that answer is 10. So this was a very easy problem from the chapter matrix. Okay, so in this problem we have to find the area bounded by this given curve, so minimum of these two curves. So first let's draw the graph. Okay, so this is 6x minus x square. It is a downward parabola. So roots we have 6 comma 0, and this point will be 0 comma 0. and another line we have, that is y is equal to 2x. So we have to find this point of intersection. To find this point of intersection, we have to solve this 2x with the given downward parabola. So that will be x square is equal to 4x. So x is equal to 0 and x is equal to 4. One point we already have, that is the point of intersection. Another will be 4, and from 2x we will be getting 8. So this point is 4 comma 8. Now for the minimum of that, so this will be the minimum. So we have to find this area. So this area we can divide into two portions, that is, let's say delta 1 and delta 2. This point will be 4 comma 0. Delta 1 is nothing but a triangle whose base is 4 and height is 8. So half of base is 4, height is 8. So this is, we have 16. Now to evaluate delta 2, we can write the integral. Limit is varying from 0 to limit is varying from 4 to 6, and fx we have is 6x minus x square dx. So we have to solve this integral. So that will be 6 into x square by 2 minus x cube by 3. Limit is from 4 to 6. So after evaluating this, we will get the answer. So this is 3x square minus x cube by 3. Now it is from 4 to 6. So upper limit if we put, that will be 3 into 36. 3 into 36 is 108. Okay, we will solve. And that this will be 216 by 3. That is 6 cube minus 4, that is 16 into 3. 16 into 3 will be minus of 48 and plus of 64 by 3. So this we have to evaluate. This is 108. This will be 7 and 2 minus 72 minus 48 plus 64 by 3. So that is 108 plus 64 by 3 minus, this will be minus 120 minus 120 plus this is 64 by 3 minus of 12. So this will be 64 minus 36 by 3. So that is 28 by 3. So that required area is A. So we have to evaluate 12A. So required area is 16 plus 28 by 3. We have to evaluate 12A. So we have to multiply this by 12. So now this 12 if we are sending inside, so this is 16 into 12 plus 28 into 4. This we have to evaluate. So that will be our answer. So 16 into 12, that is 160 plus 32, that is 192, and 28 into 4, that is 112. So this is 4, this is 0, this is 3. So answer is 304. So we are getting answer 304 square units. That is the area bounded. So little calculation is there, nothing. So in this problem, nothing we have to do, that the line is given which is tangent to the circle. So we have to just apply the condition of tangency. So circle having a center, that is lambda comma beta. So that will be lambda plus beta divided by root over 2 should be equal to its radius. Radius is root over 50. So they're asking square of this. So that will be square of 50 into 2, that is 100. So that is our answer. This was relatively very easy problem in the JEE mains exam. Okay, so in this problem fx is given, that is in the integral 0 to x gt and ln of 1 minus t into 1 plus t dt, where g is given an odd continuous function. Okay, and from we have to evaluate this integral minus pi by 2 to pi by 2 and this, and then after that we have to write this that answer in this format, and we have to evaluate the value of alpha. Okay, so first, if we, by using Leibniz theorem, we can write f dash x. So f dash x we can write it as gx into ln of 1 minus x upon 1 plus x. Okay, it is given that gx is odd function, and we know this is also odd function. Okay, so we know that f dash x is even function. So if f dash x is even function, we can say that fx is odd function, right? Now this integral, it is from minus a to a type of fx. So this integral will be 0 because we know that fx is odd function. So now we have to evaluate minus pi by 2 to pi by 2 x square cos of x upon 1 plus e power x dx. After solving this, that we have to apply by parts. So after solving this, we will be getting alpha square by 4 minus 2. So alpha is 2. Okay, so this part is important, that we have to find that if fx is odd, so this part we need not to solve. By using this, that minus a to a fx dx will be 0 if fx is odd function. Okay, after this we can solve this integral very easily. So I hope this is clear to all of you. Okay, so in this problem, that alpha and beta are the roots of this equation x square minus x minus 1 equal to 0, and Sn is given in this form, and they are asking the value of S3. So in this type of problem, we can replace x square by Sn, x by Sn minus 1, and the constant is here 1, so we can write it as Sn minus 2 equal to 0. So Sn is equal to, we can write Sn minus 1 plus S of n minus 2. If we plug in n equal to 3, we are getting S3 is equal to S2 plus S1. S2 we can evaluate very easily, that is 2024 alpha square and 2024 beta square, and S1 we know that is alpha plus beta. After plugging these values here, we will get the value of S3, that will be 8096. So this was very regular problem. So I hope this is clear to all of you. So in this problem, that mean of the 15 observation is given 12 and the standard deviation is 3. So standard deviation square is variance. So variance is 9 and mean of the 15, so summation xi, where I is varying from 1 to 15, divided by number of observation, that is 12. So summation of xi, we are getting 15 into 12, that will be 180. Okay, and mean they gave 12. So now new mean, if we want to evaluate, so from summation xi, if we subtract 12 and add 10, that will be the new mean. So let's say x bar, that is the new mean we are saying. So that will be 180 minus 12 plus 10, so that is by divide by 15, so that will be 168 plus 10, so that is 178 by 15. That is new mean we have. Okay, now the variance we have 9. So now we can evaluate by using variance formula. So that is summation xi square, summation of xi square divided by 15 minus mean square. So mean is 12, not 9. That variance is 9. So that is minus 12 square equal to 9. So that this is summation xi square is equal to 114 plus 9. We are transferring this here and multiplying it by 15. So some value we will get, some big value, 153 into 15. So that is summation of xi square we got. Okay, now we want to write the new mean. So new mean will be, we can write summation of, so new variance basically we want to write. So by using variance formula, we can write summation of xi square minus, we have to do 12 square, that the wrong entry, then the right one is 10 square, and whole divided by 15 minus new mean we got 178 by 15 whole square. So this will be that variance we are getting, and we have to evaluate this value. So after putting all these values here, we will be getting that value, that will be 2429. So some calculation will be there, otherwise it is simple problem based on that variance and standard deviation. So this problem is based on the expansion. So we know that sin x expansion is x minus x cube by 3 factorial and so on. Cos x expansion will be 1 minus x square by 2 factorial. Rest of the terms I am not writing because it is not needed. So first of all, what we will do, we just divide it by x square and multiply it by x square, so we can use this as 1. Okay, okay, we can do this. So and ln of 1 plus x expansion is x minus x square by 2 plus x cube by 3 and minus this. So ln of 1 minus x will be minus x square by 2 minus of x cube by 3, this way, right? So just we have to put all these expansion here. So we are getting 3 plus alpha into x minus x cube by 3 factorial, and beta times of cos x will be 1 minus x square by 2 factorial, and minus of x minus x square by 2, and rest of the terms we need not to write, and whole divided by 3x square, and this limit they gave as 1 by 3, so we can cancel this also. So now we are going to collect the constant terms in the numerator. So that will be 3 plus beta, 3 and beta from here. Then if we collect the terms coefficient of x, so we will be getting x common, alpha, and from here minus 1, and rest of the terms. So and whole divided by x squared. So and x square term also we have to collect. So x square term will be from here we are getting x square, so we will be getting minus of beta by 2 and minus 1 by 2. Okay, so this will be the limiting value. So for this limit to exist, these two terms should be 0. So beta equal to we are getting minus 3, and alpha equal to we are getting 1. So beta equal to minus 3 and alpha is 1. So 2 into 1, that is 2, plus minus 3. Minus of minus 3 is 3 basically. So we are getting value 5. So this is very regular problem which is based on the expansion of trigonometric functions. So I hope this is clear to all of you.